We're going to be talking about triangle midsegments. We're doing the last section, 5.4 of this unit. Then you'll be taking a test and moving on to the next. All right. We're going to talk about the sides of a triangle, okay? Before we start too much into that midsegment thing, that's the main topic, but we're going to talk about when you have a triangle. Have you ever noticed, have you ever tried to make, if you took some toothpicks and cut them into different pieces, will you always get a triangle? Can you make a triangle out of any three lengths?
Yes.
Yeah.
So if I had a length here and a length here, what if I just had that little teeny length? Will it make a triangle?
No. Well, sort of if you like.
I'd have to bend.
Yeah.
You'd have to change
I'd have
the
to
angle
bend
the
that
same
one, but it would be too
Yeah.
long.
Well,
If-
when I was talking about the other one, it would have to be down.
And if I,
But it wouldn't be an exact triangle.
yeah, it wouldn't be an exact triangle. So there are some lengths of segments that would not make a triangle. So there are specific lengths of sides to make a triangle. You have a theorem that tells you, and it's called the triangle inequality theorem. So the sum of the lengths of any two sides of a triangle is greater than the length of the third side. I'm going to read that again. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. So if you'll open up to 5.4 of your homework, we're going to apply that to numbers 1 and 2.
Wait, why don't we have this? What? Wait, why don't we have this?
I'll show you guys a little bit. Right here. Numbers 1 and 2. So we have to take two of those numbers, add them together, and see if it's greater than the other one. For example, 10 and 5, I'll take those two. If you add 10 and 5, it says sum. That's why we're adding, by the way. It says that we're doing the
15.
sum. It's 15. Is that greater than 8?
Yes.
Yes. Okay, so far we've got a yes. We have to do all of them though. It says all of them. So now I have to add the 5 and the 8. What does that equal?
13.
Is that greater than the other one that's left over, the 10?
Yes.
Yes. So far so good. We've done that one. Our last, what have we not added together yet?
10 and 8.
The 10 and the 8. We add 10 and 8. Is it greater
Yes.
than 5?
Yes.
Yes. So that we got yeses on all three. So if you had a length of 10 inches and 5 inches and 8 inches, it would make a triangle. So will it make a triangle? Yes. It
Yes.
says state if the three numbers can be the measures of the side of a triangle. Yes. Let's look at the next one. 12 and 19. If I add those together, is that bigger than 7?
Wait,
Yes.
12 and, oh, you're on the other one.
Yeah, that's time we're not doing odds this
Sorry.
time. Yes, and 12 is automatically bigger than 7, so we didn't really have to do anything. All right, so what about 19 and 7?
Yes.
Yes. What about 12 and 7?
Yes. It's equal.
It's equal to
Oh.
19.
Oh.
It says in our theorem, it says it must be greater than the length of the other
No.
one.
So no.
So this is a no. This is if you had these three measurements, a 12-inch or a 12 centimeter, 9-inch, 9 centimeter, it doesn't matter. 19 doesn't really matter with the length, but 12 inches, 19 inches, and 7 inches, it would not make a triangle. Okay. All right. You have several more to practice, but we won't do it now. Okay.
Oh. Yeah.
All right. Ladies getting yourselves focused and not wanting to get to the next thing. All right. Now we're getting to those mid segments of a triangle. You have that theorem coming up in there. You're going to have a theorem that comes up. Right now, I've given you a triangle. And I've given you a line that goes across the triangle, okay?
Right.
So first of all, I'm telling you the definition of the mid-segment of a triangle. It's a segment that connects the midpoints of two sides of a triangle. So, in other words, AE equals EC,
Good question.
and AD equals DB. Not
Is that
necessarily...
a sketch that goes in our
I would put that in your triangle. Yes, I would.
triangle?
We have connected two midpoints.
Oh, can I borrow this again, please?
Yes. Is this mid-segment of...
Yes.
I was
So the mid-segment is just the segment that connects the midpoints of each side, and they have some really cool relationships. So you drew that already. And gave you some time to draw it in your Pashla book. Now, here's the theorem. I think this is so cool. Just by connecting the midpoints of two sides, this is the relationship. The segment connecting the midpoints of two sides, which is the midsegment, by the way, of a triangle is parallel to the third side. I'm going to stop there before we go any further. That means that DE is parallel to BC. You can probably see it as it is, and it is, right? then lots of relationships can happen after that because of parallel. You guys have lots of stuff with parallel. I'm going to draw some. This is not part of the theorem, but I'm going to draw them.
Technically, DB would be a bisector or a transversal, and so would EC would be a transversal.
Yes, so right here, if this angle and this angle will be congruent because they're corresponding, right?
That is so cool.
And these angles would be congruent because they're corresponding. And, oh, never mind. We'll tell that another time. Pretty cool. This is a chapter ago, Amy, and
I got the
they're-
transversal on the line thing is, but you said something.
these
talk
are
about
corresponding
that later.
angles, right?
Yeah, she got that. She just was worried about what you were gonna say.
No, I heard
No.
something.
No, don't worry about it. I almost
later.
gave you an
I was like,
advertisement, but we won't worry about it.
Don't worry.
Corresponding angles. Don't stress about the advertisement. All right, now let's go to the other thing. Let's go to the next part of the theorem says, to the third side, and is half as long as that side. So that means that if this length here was 10,
DE times 2 equals BC.
yes. So if BC was 10, how much would DE be?
5.
5. Okay.
Wait, take a step back and say that again, because I think I missed
One more
something.
time. So not only is it parallel, Amy, it's half the length.
Oh, okay.
Okay.
Yeah.
So if this right here is 10,
So you just kind
and
of
that's
put a random
5.
number there. It
I
wasn't-
did. I
okay.
picked, I said I wanted to pick something that could be brought in half easy. You know, the half, I didn't pick 712 or something that you would have to do it on a calculator. So I did 10 because you could do that in your head quickly. If that one's 10, if BC is 10, then DE is 5.
Okay. Okay.
All right.
Uh-huh.
Questions?
Uh-uh.
In your theorem over here, if you would like, in the theorem section, if you want to put a 10 and a 5 and put a little parallel marks on there, that would help you to remember it.
I just did the parallel marks. So I'm not gonna do the 10 and 5.
That's fine.
That's
That's
too
so
much
fine.
work.
Okay. All right.
It's a...
So, you drew that already. Fantastic. You had that all done. Let's do some examples. Let's do number 7. Number 7, notice they have 3 mid segments already drawn. It looks really pretty. And they're telling you that they're going to the midpoint of the opposite sides. We're going to name the segment to the one that's given. So what's parallel to VX?
I'm in.
Yes. Done.
That is so nice.
You're gonna hear me start going crazy soon because I think I've been in math a bit too long.
Hey, it's all good. I get it.
All right. That's number 7. Let's do, the next one I want to do is, I think, 10. Number 10, we're going to find the length of the missing side. We're doing number 10.
Okay.
If EF is what it's looking for, EF, if you know that PR is 10, how much is EF?
5.
Yes, because you can do that in your head. I did
that.
We just did that. I didn't pick 500 or 712, so you could do it in your calculator and know that it's 356. But all right, we're gonna do the next one is 13. Now we have an equation we gotta do here. What is?
Oh. Every time you say another number, I think it's part of like an equation thing. And I'm like,
13. Now we could say that one is half the other, or we could say one is 2 times the other. Which would you prefer?
2 times.
Me too, because I don't like fractions. I love math, but fractions are not something that I would like to do without. So if I multiply what by 2, it'll equal the other one. 2 times.
2 times.
X plus 20.
Yes. That will equal x plus 31. Right?
Oh god.
So I'm going to do the distributive property. I think I would prefer. I have to just make a decision here of which one I'm going to have positive. Am I going to have?
I would rather have the X
Me
positive.
too. That's why I was going to bring the x over and the 40 over.
What did I do? Yeah. Wait,
I was thinking that was it too, but I don't think it is. Isn't it 11? Is it?
I had negative 9.
That's what I have too. You're already at 31 and it only takes 9 to get to 40.
Okay, I think I got there, but it's like a whole
All right.
equation.
How are we doing on those kind?
Are they all pretty much going to set up the
Yes,
same?
let's do some more. Let's do number. Go ahead. Question.
If we were to divide,
Yes.
how would we set up that?
I would do it like this. You'd say 1/2.
Wait, what?
If you want to do the 1/2.
If you want to do the 1/2, put x
Oh,
plus
yeah,
31
Same.
equals x plus 20. You could
No,
then,
you
to get
won't
rid of
do
it, do
that.
like we were doing before and multiply by the 2 on both sides, which is going to be the same thing as before. Or you could just distribute the 1/2 in here to both of them, and 31 divided by 2 is an odd, it's a fraction.
Yeah.
So I think the 2 way, but that's the way you do it. Okay? All right. You're welcome. All right, so the next one we're going to do, I think, is 16. 16, this time, after we're finished finding x, we got to plug it back in.
Okay.
What is, we're going to do the 1/2 or the double?
The double.
Okay, so
I don't want to do fraction.
2 times what equals what?
2x
Two,
plus
two,
33.
yeah.
Ooh, forgot my x. 2x plus 33 should equal x
So
plus
set up the
30.
same exact way?
Yes.
And just solve it the same exact
Yes.
way? Okay. I love things that are just the same exact way.
You want your life to be the same always. I'm going to get a negative again.
Yeah, we're getting bunches of negatives.
I don't care as long as it's not like a negative something x.
Am I doing my math right? Did you guys get negative 36?
Wait.
Yeah.
Okay, good.
Wait.
I'm waiting.
I'm not even using your moment, so I'm just working on the next one while I have time.
I'm gonna make
Yep.
it 12.
That's what I got too. Now, are we done?
Nope.
No.
No, because it says we need to find SQ.
So negative
Oh,
12
so-
plus
yeah.
30.
Yeah, so I'm going to put that negative 12 in there to the x. And what is negative 12 plus 30?
18. Wait. Yeah.
So it should be 18. Now, if we did math right, if we plugged in the negative 12 in there, what should we get for
You should get
EF?
the same answer.
We should not get, we shouldn't get the same answer.
Wait.
Half
It should be
H.
half
Yeah,
of H.
half
It should
of
be a
it.
9, right?
Yeah.
So just to make sure we did it right,
Plug it in.
that would be negative 24. Negative 24 plus 33.
What? Wouldn't it be?
I'm going to plug that negative 12 in there, and
No.
negative 12.
It would be 23.
Yeah, that is correct.
Negative 24 plus 33, does that make negative, 9?
How did you get negative 24?
Okay, so I'm plugging
Yeah,
in.
it's 9, Mama.
Okay, so I got 18 here, right?
Mhm.
So, but if I plugged in a couple of pencil, if I plugged it in here, I plugged the negative 12 into the 2x.
This would
I-
just do.
Uh-huh.
It would be 2
Times
times the negative 12.
plus 33.
Plus 30?
Then plus 33.
Yeah, and then
You can just hit the plus button. Okay, that works.
sometimes it messes up when I do it that way, so.
9.
Okay,
Should
what
be
did
9
I do
because it's
before
half.
then?
I don't know. But it should be 9 because it's half of 18. So we got it. Okay?
19 is intimidating.
What?
Just a second. Let's don't worry about 19 for now. Alright. So this is what we did, and this section was very short.
Yeah.
Oh.
It took us like less than 15 minutes here. We did the inequality theorem and found out the different lengths that triangles can be to, the lengths of the sides can be to actually make a triangle. And then we did your mid segment of the triangle. You found out that the mid segment is the thing that joins the midpoints of the sides, and it's parallel to the opposite side, and it's half of that length also. Alright, no constructions. Just finding the parallels and finding the lengths of the sides.
So then we just have these 2 lessons and then a review and a test this
That's
week, right?
correct. That's correct. Any other questions? All right.